Good afternoon, everybody. It's a pleasure to participate in another PTV organized webinar. This time I'm going to talk about our Retime tool, which is a platform that we develop for optimization of traffic signals. So my plan is to go through the presentation in a way where I will be switching between the web interface to Retime and actually demonstrate how Retime works. We can do that, and then also go back to the presentation and explain why this tool we believe is a future of optimization of traffic signals. So without further ado, I'm going to actually step out of my presentation at this point, start the optimization process because it will take some time, and hopefully if for presentation today we'll have some results to show, not many, but still some. And for that reason, I'm going to exit the PowerPoint and enter my website. So hopefully can also somebody just confirm briefly for the last time I promise that you see my screen properly when I'm showing my internet browser?
Yep, looks good.
Excellent. So this is our website. You can visit it on www.retime.online. And if I click here on login and enter my credentials, it will take me to our home page, which is still like a page in progress, because this is intended really to be a fully available once you are a user that has let's say several optimization files that have been done in the past. So right now we don't have any users like that, so all of the data that you see is essentially prefabricated, but hopefully in the future this will be a great resource. This is pretty much the only page with the prefabricated data. Everything else works as I will show you. So what I will do right now, I'll start the new optimization, click on this button here, and I'll call it, first I need to define a name. I'll call it PTV webinar so that it's distinctive from the others that, okay, I'm just getting information. It's better maybe not to change the name in the middle of presentation. And then so I can actually do specify cycle lengths and similar. And I'm not going to spend time on that right now. I'll talk about that during the presentation process. I just want to quickly start this this process, and I'll specify that I want to do 10 generations and I want to have 20 solutions in my population. I'll select performance index. I'll click here on the next. Once again, I'm going to specify later what these parameters mean. I'll go here to browse to select all of the files that I want to actually use in the optimization process. Here they are all selected. I can deselect some if I want. Then I click on the next. It will take now a minute to actually upload Vissim model, and it will show me all of the signals that I have in a network, which will be actually expressed through the RBC controller files that are available in a group of files that I just uploaded. So that will come up in a second. And then what I can do next, I can actually specify, here it is. So these are all RBC files that I can optimize, and I can, if I wanted to deselect one of these, I could easily do that. I'm not going to play with that right now. I'll just click on next. And then essentially, I just send my files to the cloud for my optimization to start. So at this point, I'm going to switch back to my presentation, and we will visit this optimization process in the next few minutes, and we will see the progress. So going back to presentation, and I will again have to switch my screen. I will talk about the current practices in traffic signal retiming and explain why this approach is, we believe, better, and what we actually gain from optimization where you use a Vissim as the core model for traffic and not some sort of analytical model. Then I'm going to just give a very brief intro into genetic algorithms and what opportunities are offered by cloud computing, and then we'll show more of the options from our Retime online platform, and I'll talk a little bit about the future work. So the common practice is really when we optimize traffic signals, we collect traffic data maybe once per year, feed into our deterministic models such Synchro or HCS, and then we optimize traffic signals almost exclusively for private cars. We are not considering all of these multimodal options, which we claim that are be important for us. And then what happens is that some of the agencies are really going to use these tools just for some types of signal timing parameters. I know the agency that says, we are not using Synchro or similar tools for all of the signal timings. We'll just do recommended cycle length, or others will solely rely on these tools for the bandwidth optimization and to adjust their bandwidth. And as we say, if you put a little bit in, you'll get a little bit out. And final result is that we get the signal timings from these tools, which are very far from what is applied in the practice. And there is a long fine-tuning process where we try to now make sure that the signal timings from these tools work in the field, which usually means that by the end of the time you finish fine-tuning, you have in the field something completely different from what your model recommended. And we are kind of getting used to that, and we say, well, it's just modeling, what can we do? And then there is also a bad stigma and reputation to the modeling process. People say, why model when you can measure, et cetera, et cetera. Well, we believe that modeling is a really powerful tool. We haven't given enough attention, especially when it comes to signal optimization process. And that's what we actually want with this concept. More importantly than selling just another concept is making sure we make advances in this field, because we've been using these analytical models for the last 50 or 60 years, and we haven't really made any significant progress in that direction. And I'm not even talking about adaptive traffic control or anything similar. Just why don't we better model traffic conditions and better optimize our traffic signals when we do offline optimization, considering the amounts of the data and modeling capabilities that we have. For example, people keep talking about multimodal operations and how those are important and how it's important to adjust signals to work with your transit vehicles or pedestrian operations or bicyclists. But in reality, we never really consider any of those because analytical tools cannot model multimodal operations. And it is strange that unlike some other evaluation studies and traffic impact studies where we switch from analytical tools to microsimulation in a big way, when it comes to signal optimization, we haven't done that. So why do we want to move in that direction? Because we have so many opportunities to choose different objective functions, to use field-like traffic controllers, to properly model things that are happening in the field. We can trust, if the model is properly calibrated and validated, we can really trust those models. We can do modeling of oversaturation, which is a big problem when you use analytical models. We can have queues with the real dimensions instead of building virtual queues in the sky, essentially, as is the case with analytical models. And we can also control how much of that congestion is spilled on nearby network, which is not optimized. We have no control over that when we use analytical models. So here's just a very short example. We recently did a study. We did our best to adjust one model in Vistro, and Vistro is actually a great tool. It's just a representative analytical tool that cannot really do, it's not about the quality of a particular software, it's about the quality of the fundamental theory that goes into the software. You simply cannot model arrival of a vehicle at the traffic signal through analytical software. That is as simple as it gets. So here is just like a couple of charts to show how no matter how much effort you put to prepare your analytical tools, you cannot get the conditions which are same as the field conditions. Whereas if you put enough effort in microsimulation modeling, you can actually do that. So the trick is, and the secret is, in these field-like ring barrier controllers, and here we just have an example from the Vissim RBC controller, but I could show several other examples, including the software in the loop kind of tools from Econolite, AAC3, or from a few other vendors who by now also made their controller firmware from the field to be interfaceable in Vissim. And so what are some of the shortcomings of the stochastic optimizations? Long optimization time is the first one. That's what we are trying to solve with this cloud computing. Objective function is difficult to choose. You will see that that also doesn't have to be a problem, because we can actually let user decide which signal timing plan is going to be used based on multiple objective functions. Even if you optimize for one, your solutions do not have to stick to only that one, because you get the whole family of solutions that you can review and choose from. It's difficult to calibrate and validate microsimulation models. That's where we hope we will make a quantum leap in future, not we personally, but everybody in the industry, with a better data and better algorithms to calibrate and validate models. And then sometimes the questions are, if I have transit which is preempted, what am I really optimizing there? And the answer to many of similar questions is, there's so many things around that you can actually adjust to the constraints which are given by that transit preemption. For an example, there are so many other examples that can be mentioned at this point. And then at the end, another thing which is true for the stochastic optimizations, there is no guarantee that you are going to find the optimal solution. It's a stochastic process, and it can go forever before it finds that optimal solution. But there is also something more important. There is almost guarantee that you will not find optimal solution if you use deterministic tools, because the theory that's behind them is so not comprehensive enough to really give you optimal solutions for majority of potential scenarios that you want to investigate. So now I'm going to go back, we'll step out again from my optimization process, and we'll go back to the, and so here are all of the past optimizations that we kept in our database, and here's the one that's going on right now. And you can actually see our status page, and you can see where we are right now. So what you see here is the first, which optimization is running. Then you see its current status. It says that I decided to have 10 generations, and we are now simulating the first population of the 10. Each generation has its own population, which is slightly different from a previous generation. So we are right now working on the first one. And the next chart here shows what's happening with the Vissim simulations. None of them are running right now, which means that the algorithm is actually combining solutions. The first, the initial population was done, and the first population was done, and we have here 40 simulations have been completed out of 220 already. Imagine, like 40 Vissim simulations have been already done by the time I was talking about the previous stuff. You can see also here status of the virtual machines. We have right now 22 virtual machines, and all of them are idle because the algorithm is just recombining, and very soon it will actually show here some of the data. We actually already have what is currently, based on this one generation, the best signal timings, but our performance measures will also be populated here in a second, or actually they are just right now. And you can see that we didn't find in the first generation anything better than the solution that we started with, but that's very common. You know, sometimes it takes as long as 5 or 7 generations before we see improvement. Sometimes we see improvement in a very first generation. Actually, there could be like 5 generations consequently that each of them shows certain improvements. So I'm now going to, I will come back to the to check the status of the web page, and I'll go through all of these different tabs, and I'll show you what's in the software. Just I want to go back to the presentation and explain a little bit more of what this approach is about. So the very briefly, genetic algorithms, it's a process similar to how we evolved as human beings, or how any other species on the planet have evolved over the history. So you essentially take a population of solutions, and here solution is signal timings for all of the signals in your network. So that is one solution. So if I have 10 signals, 10 signal timings for a specific hour combined working together represent one solution. And so in each generation, I'm going to take those 10 signal timings, I'll recombine them among themselves in a process which is similar to mating as it happens with the human population. And then I'll create the new generations of solutions. Then I will evaluate that new generation. And by evaluation, I mean I'll send all of these signal timing plans to Vissim to model and investigate how good that particular objective function is. And in this particular case, we select the objective function to be performance index, and then it will save the best solution, preserve for the next generation, and others will be recombined again before we send them again back to clouds to be simulated. And here is actually a simple flow chart which shows how that process works. It is quite simplistic, where the trick is really to know how to encode properly signal timing solutions in genetic algorithms, and how to do combinations in the most effective way. And the power of this is if you do parallel processing, because once you have all of your solutions ready, whether 10, 20, or 200, you have to have so many machines to parallelly process all of these different solutions. That's where in the past these genetic algorithm processors were relatively slow, and now with the cloud computing we can really do wonders, because it allows us, with the current also licensing agreement with the PTV, to run theoretically hundreds or thousands of machines at the same time. I say theoretically because we haven't tested more than 100, but even 100 is a lot. And you can see right now I'm running 20 just for the sake of having a shorter processing times, but we essentially integrated this parallel computing process in Microsoft Azure, and that's something that is happening in the background. So let me step out of this presentation again for a second, go to my cloud platform, and you can see in the second generation, again, we haven't seen any improvement. So this is like Murphy's Law. When you need improvements the most, like in a presentation like this, things may not work as perfectly as they work sometimes when you do it for your internal purposes, but that's completely okay. I even had cases sometimes in the past where I'm displaying this process to some of the potential partners, and 5 generations pass and I don't see improvement, and I'm starting to even question if we made a mistake in our latest code somewhere and something is not working well, and then it suddenly shows a big drop and it shows that it has a significant improvement of 5% or more. It depends. So, but you can see here that we are already done with the 60 of Vissim simulations, which is kind of impressive. And when we finish the results, you are going to see that it's not just about finding a better solution, but all of the analytics that you can do with the entire population of the solution that we go through. So let me just show you quickly right now what we have on the Azure, where the things are happening. So this is my Azure account, and it shows that all machines are idling, and that is exactly what I get here on my status. But I can also show to my go to my PTV Vissim jobs, and let's see what's happening there with with the Vissim simulations. If I click on this task button, it shows me actually that all of these Vissim simulations which have been completed so far, and there is another batch of 20 simulations running. Let me go then back again and check on my pools. So since they're running, I'm supposed now to see that machines are not idle. No, they are not. You can see that 20 of them are running, and we have 2 idling machines, just in the case that, you know, some of them are stuck or something like that. If I go back to my status, you can actually see again here that 20 of them are running, and we are already done with a 60 out of 220. We haven't really seen improvement in the performance index, but that again is something that will come soon. So going back to my presentation again, and I apologize for switching back and forth, but this is the only effective way to cover both things. I already show you how potentially where is our website and how to log in. I show you the home page, and here a little bit about the inputs. It's relatively simple to define the optimization process. You just, from the signal timing parameters, what you need to have is RBC files which have a certain signal timings integrated in them, and that is something that comes from your original Vissim model. That's probably something that reflects what's already in the field, or signal timings that you want to start with. That can be the best signal timings from Vistro or from Synchro or from any other. It doesn't have to be best. If you put somewhere that's not perfect, that's not optimized, the optimization process is still going to give you good results. So then you define duration of the simulation period. If you want 900 seconds or a full hour, 900 seconds is actually 15 minutes. And we found that sometimes that's what is enough. You want full hour, that's perfectly fine, or 2 hours. Only problem is that it will be 4 or 8 times longer, and it will take more resources and more time to finish the optimization process. And then, as I said, you specify how many generations you want and what is your population size, and you specify what you want to be your objective function. We have a full range of different objective functions, and we will keep adding them. There is a good chance we'll have probably 20 different objective functions that could be used for the optimization process. Then you also select what you want to optimize. You don't have to optimize all of the parameters. You could optimize only cycle length, or only offsets, or only splits. And then we also have opportunity to say, if you don't want your minimum phase times to be included in, to include pedestrian times, people who are familiar with the signal optimization process know that if you integrate your pedestrian times in your phases, you may get a longer cycle length, and then in that case, you maybe pay a higher price for the delay, but your signals are never going to go out of sync. If you want to keep your cycle length lower, every once in a while, when you have a pedestrian on a corridor where pedestrians are not maybe so frequent, a pedestrian pushes that button, you go out of sync. We have opportunity to optimize for both options, which give some folks really a great a chance to play with how they want to optimize their signals. I already showed how to upload signal timings and how to go through this process, so I'm going to skip all of these slides. We already had a chance to see the status page. I'm going to skip that one too. And is there anything else that I need to mention here? So once again you load your files on the cloud, the optimization goes uninterrupted unless you want to stop it. That's also an option. I'll show you. There is a button there. If you see that you let's say you wanted 200 optimizations, but after 200 generations, but after 100 generations, you are already happy with your solution, and you don't want to wait any longer. You want to stop the optimization process, you can do that, and all of the solutions are saved and nothing is really interrupted. So this is also a few slides that I already had a chance to show. So few things, and I can probably now move back to my cloud platform. All of these charts are actually updated automatically in real time. So other than waiting to make sure that you give enough time, the process itself is actually slow. When you consider what's happening here, this is not a perfect. So we already have some improvements. We went from the 76.7 to 75.4. Not so much of an improvement, but still better than nothing. And so when you think about this whole process and how what's happening in behind, it's a relatively slow process. So to show this in real time and see improvement and progress, it's actually quite good and amazing, because this is, imagine you're running like dozens of simulations in real time and you are already seeing some results. Here is the stop optimization button, and as I said, all of these charts are updated in real time. And I can now move and I can show you some of the other charts. Let me just remind myself what are the things that I want to focus on. Okay, few other things before I actually move to before I move back to the platform. This is one important thing that I wanted to show. This is something that we still don't have as a part of integrated in our platform, but this is something that we have in a background. So it's a matter of days, probably not more than a week, to actually get to these time distance charts with the very realistic trajectories of all of the vehicles that go on the major directions on that corridor. And of course, you can also see like a number of performance metrics that could be extracted. Not super relevant really for the entire chart, because each of these is supposed to be extracted for individual intersection. But this is just to illustrate what we are planning to have for the both for individual intersections and for the whole corridor possibly. So here is just an example that we kind of extracted from one of the previous optimizations. This is still not possible to see in the tool, but it will be there very soon. So you can see, for example, how in the eastbound direction, initial signal timing plans had a lots of delays at certain intersections, and then for the same traffic flows, once that plan was optimized, you can see that actually the flows through the intersections are much better. It's still not perfect, because obviously for a number of reasons like geometry and speed limits, varying speed limits, this corridor has, I believe, like 3 different speed limits on this set of 12 or 11 or 12 intersections. So optimization of the bandwidth is always tricky. Geometry and speed limits play an important role, but you certainly can see here a significant improvement. And while we haven't really optimized for the sake of doing bandwidth, this time distance charts and ability to see how the platoons progress through the corridor is one thing that will be available for any signal timing plan that you want to check. So that is not really part of the optimization process per se. That is, once you finish the optimization process, you can select any solution, which is group of signal timing plans, and you can develop the time distance charts and show how good your progression is. Using some very realistic trajectories, if you will let me notice, because here you can see for a number of trajectories, they disappear in the middle. And that's exactly what's happening in our Vissim simulation model. Sometimes they will just like turn on a local road. Sometimes they will turn into a left or right turning link before the intersection, and just they disappear for your true movement. We don't follow them anymore, because if we did, it would be really just much more messy on a chart, and it wouldn't really help our purpose. So at this point on, I think I'm better off if I go back to the platform and show you. So what are the things here? We still don't have our 4th generation done, but I can show you actually on the map. We have this entire corridor on the map, and I can click on any of these signals, double click actually, and it will show me for that specific. Actually, this is maybe okay. So if I select the data may not be populated. So I'm going to go to past optimization. That is actually a feature which is much better to show on past optimization. So this is one of our past optimizations. And if I double click on the signal here, it actually shows me the best signal timing plans for this signal. So I have the initial from this optimization effort here. I have what was the initial signal timing plan and what was the optimal final signal timing plan. And this is case for that specific signal. If I go back to the map and if I select another signal and double click on it, I can also see from that optimization process what was the initial signal timing plan for that signal and what was the final signal timing plan. And of course here, I don't have to show only best. I can show actually any signal timing plan number from any generation that happened during that optimization process. If I click select, nothing has happened, but actually just another plan that I just selected in the previous case showed up below here. And if I do another timing plan, another generation, and I click select, just one more timing plan will be added. And you can see here for each timing plan, what is the number of the timing plan in the population and what is the generation number. And I don't have to select here only timing plans for one signal. I can even select a different signal and get the same first initial and best. And then if I really wanted to, I can also select a different plan number and different generation number, and I just keep adding. So this is like a nice feature so that I can quickly and easily compare signal timings from all of the solutions during the optimization process that were investigated. I know what were the values that I was comparing. And then the other thing that we can do for optimization results will always show me the final table, which shows what was the best performance. So in this particular case, when we optimized this network, we were able to achieve performance index of 72.46, which was the best. We probably just finished, like you can see, it was a relatively short optimization of only 21 generation. And then if I wanted, I can actually download here. First, I would have to actually select a specific solution from the generation number 4, signal timing index number 4. I can actually select traffic signal settings and download them. Here is an Excel file. If I open this Excel file, you'll see the format of my signal timings. It went to my second screen. Hopefully you can see here. So all of the signal timings are downloaded as Excel file, and I can also download the performance measures. There are a few others that we are planning, so I'm not going to open this one. We're kind of running short on time. But there are a few other options that are still work in progress, but essentially this page is where you can see the final results and you can do the downloads. Then there is a page with the performance charts, which is helping us to see how any of the performance measures that we have in the optimization process, we're collecting all of these performance measures. These charts here show all of them. Actually, whatever you select to show, I can keep adding charts here until I run out of the performance measures that are actually recorded during the simulation process. And this is what gives you a great ability to really see how all of these different performance measures how are they evaluated during the optimization process. Sometimes you will see some of them are improved, some of them are worsened, and that's all okay. You have ability to choose and decide what you want. But this particular performance chart shows for each of these performance measures how they vary during the optimization process. But if I go to sorted charts, this one will show for any performance measure that I decide to show in a ranking or ascending or descending order specific performance measures. So for example, I know here that number of arrived vehicles for me was the highest for generation 21 and lowest for the generation 1. But this is not always the case. Sometimes I'm going to have the case where some of the performance measures will be lowest for a specific during the specific generation. You see, for example, here we have this is generation 17, but this one is generation 5, and this one is 6, 7. So obviously, it doesn't have to be really given in a order. It all depends when specific performance measure was better or worse than the others during the optimization process. And again, I can keep adding all of these assorted charts on this page as long as I don't run out of performance measures. As a matter of fact, you can add as many as you want. Even if you run out of performance measures, you just keep adding the same group of performance measures. And finally, one of the most important charts is the Pareto chart, which shows Pareto fronts. And this one is interesting because it shows actually two performance measures and how they can be traded off. Like this one here shows numbers of stops and delays, and we have a curve which shows the Pareto front, which means any of these solutions on the Pareto curve means that you can improve one of these two performance measures only by worsening another. So in other ways, this one is already very good both in terms of the delays and stops. But if I wanted to reduce the number of stops further to come, let's say, to this point, I would have to increase delay. And vice versa, if I wanted to reduce delay from this point to this point, I would have to increase number of stops. So which exactly solution you choose here on this curve, all of the solutions on the curve are optimal, but which one you choose to select is based on your preference. What do you prefer more? Fewer number of stops or less delay? And what is also very interesting here is that each of these points on the chart, it's a clickable. So you click on that point, it's actually a solution which consists of all of the signal timings which are contributing to that solution. And here you can actually see for that specific solution, what were the signal timings values for each signal, and what was the performance, and you have it also in a tabular form, and what was the performance measure. And so you could actually on this chart find a solution that is not given as the optimal by your optimization, but for some reason you like it because it maybe gives you, like if I click on, let me click on one of these optimal ones. So it will open another page, and it will show me again all of the performance measures, and it will show me the tabular form of all of my signal timings, and then ring barrier diagrams for all of the signals and their signal timings. So this really give a great opportunity for us to dive into the entire population of the solutions and select the ones that we like, which is something that we don't have ability to do with most of the other signal optimization platforms. And I think at this point, I can go back to my past optimization and see how my current optimization is performing. So you can see here, actually, we are already done with a five optimization, with optimization steps with 5 generations, and we have reduced performance index by almost like somewhere more than 5%, 72 divided by 76.5. So that's 6% improvement already in the performance index, and we are only done with a five generations. So actually, I believe this entire optimization process could be finished to somewhere close to a full hour. So imagine 20 solutions and 10 generations, that means that 200 different Vissim simulations have been done in 1 hour. So while this tool is not something that is comparable to Synchro or Vistro or similar tools where you finish your simulation in an hour or less, 30 minutes, 15 minutes, you can finish your simulation, your optimization overnight. And in that case, in 10 hours, you get maybe 2,000 solutions, and all of the solutions are recorded in a database, and you can do analytics afterwards, and you can play with the different objective functions and find what is best for your particular network. And let me not forget to mention here that we haven't really thrown in at this point any stories about multimodal operations. That's something that we can easily do, but it's one of our next steps. And maybe at this point, I'm going to keep this optimization running. I hope I haven't forgot to mention any other features which are supposed to be showcased here. I can maybe quickly go back to my presentation and potentially open the floor for the questions, because I believe we got 15 minutes left, and I would like some of those 15 minutes to be used for your questions and for the answers. So Adam, if you want, you can now interrupt me at any point, and I just have all of these screenshots or most of the screenshots recorded in the presentation for you to review later. I believe the presentation will be made available by PTV. So all of these slides are really there. I don't have to go through them. They're for your records, and I'll be happy to. Yeah, another thing that I didn't show, I'll show you maybe in a few seconds later. These charts, all of them are zoomable. Actually, you see so many solutions, and you're like, how will I be able to recognize here? You can actually zoom in, and you can closely select the one that you potentially want to open and investigate.